All equipment featured in this video can cause serious injuries. Please make sure you are familiar with all safety precautions before attempting anything seen in this video. Just waiting for the chopper to pass. Steady hit it. Is it gone? He's gone. Okay. Take one. Action. That is a little grey hair. That is a little no hair. And that is because of people cutting circles on a table saw. Even if you can only afford the cheapest table saw known to the cave of man, you probably own a jigsaw, you probably own a router, and you probably own a bandsaw. And all three of those can cut circles. You're watching Wood Nail and Hammer. My name is Stefan, and there's a couple of things I'm willing to do on a table saw, but circles ain't one of them, and this is why. When rotating a board to cut a circle, both hands are moving directly towards the spinning blade, increasing the risk of injury compared to normal rip cuts, where the hands move parallel with the blade. Even the use of a blade guard does not eliminate the risk of injury, because the moment the workpiece lifts the blade guard, the hands can easily follow. One should also consider that the use of a riving knife will not lower the risk of injury, because the workpiece must pass the riving knife in order to prevent kickback, which does not happen when cutting a circle. Therefore, the hands can also be pulled towards the blade by kickback. So don't make a circle cutting jig for the table saw, rather make a circle cutting jig for the router and cut some circles without investing any fingers into the busyness. I used an acrylic sheet of 3mm thickness, and I doubled that by making 2 layers in order to have an adjustable slider rather than having fixed distances from the pivot point. It was my first time cutting acrylic with a router. Since I'm not an acrylic expert, I thought this was a clear acrylic sheet. Clearly this is white acrylic, and it had this horrible melting result on the cutting edge. With the second cut, I decided to do a second pass, and that seemed to clear up most of the melting. So that was a big lesson I learned in this project. Next time, I'll be sure to buy clear acrylic. I joined the two pieces by drilling and tapping holes for 4mm bolts, and the hand of the king provided some much needed assistance. In order to allow enough space for the tap wrench, I had to replace some clamps with bolts, but I removed them again after tapping in order to countersink the holes. The upside down reversed image of a number 1 almost looks like a J. I prefer to mark the matching corner this way to make sure the whatever I'm busy doing still looks like the whatever I'm busy doing when I'm finished doing whatever I'm busy doing. I was planning to leave this jig in a rectangular shape until one of the corners broke off while countersinking the holes. I drilled and tapped a new hole for the time being and then figured I might as well finish the jig by cutting it into a shape that avoids the broken corner. And that is how you turn a disaster into your own design and brag about how you planned it all along. But more about that later. For now, let's take a look at the most accurate hole I've ever drilled in my whole life. I started with a 3mm drill bit and then also used a 3mm router bit for accurately aligning the router with the point of cutting. My first try to mark the mounting holes didn't work because some inconsiderate astronaut invaded my space and blocked my view with his LED lunar module.
Unknown round shapes detected. Surface scanner initializing. Scanning. Processing. Results in 3, 2, 1.
Houston, some crazy old caveman from the southern hemisphere is trying to drill holes in the moon. Dude's invading our space. Lunar surface unsuitable for landing. Mission aborted. Returning to base.
So I kept the speed square in the same position and then aligned the center of the guide plate with the center line on the jig so that I could use a handheld drilling machine to mark the correct location for the holes and finish this video before lunchtime. Not sure lunchtime on which day though. I also added mounting holes for the plunge router because nobody else does it. So I will have a jig like nobody else has. I prefer to use tapped holes for mounting the machines as well because that will provide better stability. Bear in mind that the trim router uses 4mm bolts and the plunge router uses 6mm bolts. That might be an industry standard, but it's always a good idea to make sure you're tapping the correct sizes. Tapping the incorrect sizes might cause you to have to start all over again and make a new jig, which will not be finished before lunchtime. From this angle we can see two things, my accurate drilling skills and my router that needs a good cleanup. Since that groundbreaking countersinking disaster of 4 minutes ago, I decided to rather use the trim router to countersink these holes. For enlarging the cutting hole, I drew a circle slightly smaller than 19mm and I did a freehand cut up to the line using the trim router and a 6mm straight bit. I then finished it with a plunge router and a 19mm straight bit. It needs to be done this way because the blades of larger straight bits are not wide enough to remove material in the center. Since this jig wasn't unique enough already, I decided to also mount a jigsaw, but I first had to drill and tap mounting holes in the base plate. The rest of it was done pretty much the same way as the routers. Just note that in a case like this, it's better to mark the location of the mounting holes on the jig before you tap the holes in the base plate. You don't really want to use a drill bit in a hole that has been tapped already, because that will most definitely damage the thread. Although I'm skeptic about accurate cutting with a jigsaw, I still wanted to give it a go, just because there's really nothing to lose about it. For cutting the slider groove, I used the plunge router. I also did 2 passes every time and took a little break halfway through to spray some lubricant on the cutting bit in order to reduce heating. The result was way better than using the trim router. The first groove was 6 mm wide and it was cut all the way through both pieces. The second groove was 16 mm wide and it was cut 3 mm deep from the bottom side. The center of both grooves should perfectly align with the center of the cutting hole. It comes to mind that I could have separated the pieces for cutting the second groove, which would have made a cleaner cut, but on the other hand, it's also a good thing to keep an eye on accuracy while performing the cut. Take a look at the Battle of Bluetooth to see how I made that beautiful tripod stand. I will leave the video link for you on the end screen. I used a small piece of clear acrylic to make the slider. I first drilled and tapped the necessary holes before cutting it out with a jigsaw. I prefer to use a metal cutting blade when cutting acrylic with a jigsaw. Although I prefer to use pliers when sanding small pieces on the belt sander, there might be some times during shaping that it's not possible. Bear in mind that a belt sander can cause injury by bouncing the workpiece. You probably won't lose a finger, but those sharp edges might draw some blood. Be sure to always wear safety glasses. This might not be perfect, but if perfect had an annoyingly close neighbor, that would be this little guy. Finally cutting the jig into a shape like this avoided that historical countersinking disaster of 1910 minutes before, but it also required 4 new holes to be drilled and tapped on the inside before cutting the shape. This time I tried cutting the white acrylic with a jigsaw and the result was not good at all. The acrylic instantly heated up and liquefied, and after cutting it immediately cooled down to a solid state again, making it impossible to separate the two pieces. Therefore I switched to doing a freehand cut with a trim router. It is important to maintain a balanced cutting speed with both routers. Moving too slowly will cause heat and melting, but moving too fast will cause too much workload on the machine. For better stability, I prefer to use a 4mm pop rivet in the pivot hole. If necessary, the sticker can be wrapped around the pop rivet to make a tighter fit. The last thing you want when cutting a circle is a wobbling pop rivet. I just had this feeling of my jig not being unique enough already, so I added this little guy, and I'm pretty sure you know exactly how I made it. Let's call it a pencil insert. And the use of it? You insert a pencil and first draw the circle you're planning to cut. Why? Because you measure twice and you cut once. That way, you measure twice and you cut once. And monitor the accuracy of your cut while you cut. And that is what I meant with a tighter fit. With the trim router, I only succeeded in cutting a circle on the second try. On the first try, the slider moved due to cutting 7mm deep on each pass using a 9mm bit and probably moving too fast, which also caused the depth lock of the router to fail. That clearly shows that the trim router was not meant for such a workload. On the second try, I did not exceed 5mm depth per pass and I used a 6mm bit. I also moved slower, but the depth lock still let me down slightly, which was not a big disaster since the plan was to cut through the entire board's thickness anyway. I just reset the depth and finished the cut. If however I was only cutting a round groove and depending on an exact depth, it would have been a bad day. This circle took me 4 passes to complete. The plunge router is the winner in this video for doing the best cut on the acrylic as well as the wood circle. It seems obvious because it has a stronger motor compared to the trim router, but the depth lock is also way more stable than that of the trim router. Should you only need to cut a round groove, the result would for sure be accurate. I also did 4 passes of 5mm at a time. Theoretically, one shouldn't exceed half of the router bit's cutting diameter in depth, but since pine is a softwood that generally cuts very easily, I guess that justified bending the rules slightly. I would not recommend doing the same with hardwood species. Due to the vibration of the jigsaw, the slider kept moving, causing inaccurate cutting. I added these rubber washers, hoping that they would provide better support. Unfortunately, the slider still moved while cutting. I then mounted another jigsaw that has variable speed control and tried to cut at a lower speed in order to reduce the vibration. That, in addition to the rubber washers, seemed to be successful. However, due to the flexibility of the jigsaw blade, the cut was still not accurate. Since already being able to do accurate cuts with both routers and being able to do a better freehand cut with a jigsaw, I decided to not pursue this any further. I might try this again sometime, but for now, I'm very thankful for having a plunge router. Did I say freehand? Of course I did. Let's go there. When cutting a circle freehand, I prefer to have the circle drawn on both sides of the board. Simply cut as close as possible to the line without crossing or touching the line. 1mm is a very good distance to minimize the amount of sanding that will be needed. Be sure to use a blade with more teeth per inch to avoid tearing out and losing your cutting line. This is why I prefer to have the circle drawn on both sides. You can hardly ever expect a 90-degree edge when cutting with a jigsaw. Now you can sand it down to the line and flip the board over to make sure it matches the line on the other side as well. This is Perfect's other neighbor. He might not live annoyingly close, but at least Perfect can see him from his front porch. This is the circle that went south with the trim router's first cut. I reduced the radius and also did a freehand cut with a jigsaw. This time I'm only sanding one side to the line so that I can use the flush trim bit with the router to cut the 90-degree edge. For best accuracy, adjust the router as deep as possible so that the bearing on the bit barely touches the sanded line. Do the first cut with the bearing on the sanded side and then do a final pass from the other side. You might still need to do some sanding, but using a flush trim bit will definitely reduce it. Remember to cut at a moderate speed, maintaining a firm grip on the router, and do repeated passes until the bearing meets the sanded line. The general rule of thumb is that the operator guides the machine and the machine does the work. There are many ways to cut circles. You might even consider doing it with a bandsaw, which is very similar to the freehand method I've shown. There is simply no reason to cut a circle on a table saw. Thank you for watching. If you enjoyed my video, please consider subscribing. Comments and suggestions are always welcome. And remember, any day that ends with 10 fingers is a good day.
That's a little grey hair, and that is a little no hair, and that is because of trying to make a circle look like a circle.